Dr. Miljana Horvat, Associate Dean, Graduate Studies at the Faculty of Engineering and Architectural Science. Welcome to Operation Breakthrough, Innovations from FEAS, a new initiative from the Office of Social Innovation held in partnership with the Faculty of Engineering and Architectural Science. In this series, we bring together students, researchers, and educators from Ryerson University to share innovations that they have made in response to COVID-19 and societal changes that have occurred.
Hello, everyone. Today we have an interdisciplinary team from engineering and the Faculty of Communication and Design from the Fashion Department. And the title of the project is Engineering COVID-19 Fashion, Designing the Most Effective Face Mask for the Canadian Fashion Industry. So I'm going to first ask you to quickly introduce yourself, your name, your position, your department or program, area of study, and what was your part of the project?
Okay, my name is Hyejin Lee. I graduated my fashion MA program last year during the pandemic year. And I'm a part of a design team for this project, which is led by Professor Daniel Martin in fashion program. In the team, my role is developing pattern with the most efficient source of material to find the best combination to protect us from all of the droplets.
Hi, my name is Lordly. I'm a Master's of Applied Science student in Dr. Omri Karatas's lab in the Department of Aerospace Engineering. What I do is the physical testing of these, of the characteristics of the respiratory flows with the face masks that Hidi and the fashion team provides us. So we use imaging techniques and high-speed cameras and lasers to detect the airflow of the system.
Hi, I'm Leya Kober. I'm an undergraduate student at Ryerson studying mechanical engineering, and I work with Professor Seth Dworkin doing the numerical modeling for this project. So we do numerical CFD simulations of cough droplet flow within a domain to sort of figure out safe conditions, varying things like temperature, humidity, airflow, and then droplet flow across masks to determine their effectiveness.
Thank you. So I know during the COVID time, the necessity for invention, especially in this area, was obvious, right? But can you tell me a little bit, what was the inspiration for this project from your particular perspective?
My personal inspiration began from when I started to make masks for my family and friends. Then I started to realize actually not every design is suitable for different face shapes and sizes. Then that thought expanded to the 4,000 masks with the Ryerson fashion department that we partnered with the local hospitals. So we team up with the whole department, the students and faculty members, and provided 4,000 masks. From that point, the Professor Martin asked me if I would want to join this project, which is like, for me, was a perfect opportunity, not just making, it's more for thinking about what would be the most efficient design, protect us. So that was my inspiration for this project.
Thank you. So what were the challenges that, if there were any, in conducting this project?
I think that challenges comes to the design team because we still wanted to cover all the different shapes and sizes. But because this COVID situation, we do not really have any access to like meet with the real people, measure the sizes and do the fitting. And as well as actually sourcing the materials also challenging because this lockdown situation does not give us that much access to different stores. So that, yeah, was a little bit challenging. We're still working at it, and we are developing, we're actually trying to use a 3D Cloak program which actually we allowed people, the scan people, and they developed the 3D model, and then we developed the size and fitting on the 3D models.
Do you need volunteers? Subjects for testing? I would be happy to be subject for testing.
We were actually talking about it, but yeah, we just have
I'm sorry, I'm interrupting the flow, but yeah, I think it's an excellent idea. So how do you feel that this project advances the social justice and benefits society? I mean, you know, some of the answers are obvious, but I want to really hear it from your perspective.
So I can answer to that. So our team is very committed to equity, diversity, and inclusion principles. You know, we have a very diverse team with people of many different cultural backgrounds. We have a good gender balance. Our team is interdisciplinary. So we've got people from more of a science background and then people with more design-oriented background. And then not only that, we have people working together from different levels of academia, from the undergraduate level up to the PI level. And so this is really important in inclusive design, because in inclusive design, you need to have as many different perspectives as possible, so that the end product that we're working towards is as accessible and respectful to as many different groups as possible. So with this project, we want to keep in mind, especially those groups in our society who have been traditionally underserved, such as those who wear cultural or religious beards and headwear, and groups such as Indigenous peoples. So as a researcher and academic, working with such a diverse and interdisciplinary team really helps me personally to expand my own network, and I'm sure everybody else on this team, which helps make my work more introspective and inclusive, which is something I can apply outside of the world of academia. And inside of inclusive design, one of our main goals is to provide information to the general public on best ways to keep themselves safe in easily accessible formats through open access publications, posters, social media, in ways that are easy to digest for the public. And I think with this extra information, this is going to help to ease some of the anxiety that people feel surrounding their safety during a pandemic, and ultimately help to reduce deaths, especially for those who are disproportionately affected.
Thank you. I really agree with you. So how do you see the way forward? What are the ways you see this project going just beyond the COVID pandemic?
I can touch on that. Well, of course, right now the project is very much COVID related, but what is learned can really be applied to like any type of airborne diseases. Right. So at the beginning of the pandemic last year, and even now, there was and still is uncertainty on the characteristics of the transmission through the air, the effectiveness of various masks, and essentially how to minimize the transmission. So for COVID, right now, a year later, we finally have vaccines starting to be distributed, which will effectively lower the cases and transmission rates. But for any airborne diseases, I guess, in the future, there will, of course, be some time between first cases and when and if a viable vaccine is developed. So with this research, having a better understanding of these mechanisms through the airflow, the mask efficiencies, will basically help to minimize the initial spread through that timeline.
Thank you. I really thank you first of all, for the excellent idea, for the work that you've done, for this amazing collaboration that really bridged engineering, science, and design. And as Leya mentioned, the all levels of academia, from undergrad to graduate students to professors and technical support. And I thank you all, and I wish you all the best in the future.
Thank you very much. Thanks
you.
for this opportunity.
Thank you for joining us. To learn more about Operation Breakthrough or to submit your own innovative project related to COVID-19, please visit ryerson.ca/social-innovation/operation-breakthrough. Goodbye for now, and I look forward to seeing you in our next interview.